I've put together some scientific evidence to reveal to you what we are made of. So let's take a look at this particular website. And here we can see, and you can also, based on what I've shared with you, research yourself and you'll find that it's very interesting actually. So, our human body, the elements that make up the human body are as follows: oxygen, carbon, hydrogen, nitrogen, calcium, phosphorus, potassium, sulfur, sodium, chlorine, magnesium, trace elements. So, as you can see, essentially, we are made of molecules, right? And with these molecules, if you hone in, they are of course made of atoms. And then later on, we'll look at what is beneath these atoms and subatomic particles, all right? To have a full understanding of who we are. So let me now turn on to the next article, and this is from the HeartMath Institute. It's in the United States, and what they have essentially found is that we have energy field, right, around us, our brain and our heart and the entire body. But the strongest detection is actually from the heart and also the brain. And they have gone on to research into how the coherence between the heart and the brain, which I will I will not be going into detail over, for now in this video, and I'll leave it to you to explore, right, by reading the article in the website of HeartMath Institute. So we are essentially made of energy, right? Because we have this energy field as shown in this experiment. Now, let's see what else. Aside from this, we also have another article that shows us that, here we go. Underneath this subatomic particle, we have quarks, leptons, and all this. But in 1964, there was a scientist. His name was Peter Higgs, and he, together with his team of scientists, put forward that underneath all these subatomic particles, you will find there is an energy field where all particles have to go through to get its mass. And this was way back in 1964, if I remember. And, well, to prove that, they had to build, it cost about $10 billion, at CERN in Switzerland, Large Hadron Collider, which is 20 over kilometers long. And this is the website of CERN, all right? CERN is where the experiment was done. It's essentially colliding particles to simulate the Big Bang. And from here, they can see what happened when the Big Bang occurred, and to understand also about what is beneath the subatomic particles. So this is a website, home.cern, and you can read all about it. Essentially, in 2012, after having spent, as I mentioned, $10 billion US, 7,000 over scientists, they have actually proven, right, in 2012, that what the scientist Peter Higgs said was true, and that's why they call this the Higgs boson, right? They named after him. And essentially, as I said, what it does is that it gives mass to the elementary particles when they pass the Higgs boson. Okay, so what this proved to us is yes, um, we are made of energy. All right. So scientifically, it has already been proven that we are made of energy. Now, it hasn't stopped there, right? Because some of you who are into astronomy and physics and so on, you probably heard about the term quantum field, quantum entanglement, and so on. The universe is what we see is essentially around 5% of light. There's another 95% that is not visible to the naked eye. And this is what they call dark matter, because how then are galaxies held up together unless there is a field, a force? So it's known as dark matter. Then for a bigger portion of it, because our universe is expanding rapidly, and what is the force that pushes this expansion? Then we have what we call dark energy. All right, so it gets a little bit more complicated, and I have here an article about quantum experiment, and this was quite some time ago. All right, quite some time ago. It was published in New York Times. You can read all about it, and essentially, I'll summarize it for you. Dr. Nicholas Gisin, University of Geneva. Okay, he did an experiment where he split the photon light, all right, into two. So it's a twin photon experiment. So from one photon split into two, and then he sent one to one direction, let's say north, 7 miles north, and the other one 7 miles to the south, using fiber optic cables. Okay, and then after that, what he did and his team of scientists did was they manipulated one photon, and strangely enough, the other photon reacted. Okay, so this seems pretty impossible even to Einstein, right? So I think Einstein said something about spooky at a distance, right? Something about spooky, something at a distance. Yeah, spooky action at a distance. That's what Albert Einstein had to say about this quantum entanglement. So what this essentially showed us is that even though the photons have been split, one sent to one direction, the other one sent to another, but somehow they are still entangled. All right, so just take note of that. Quantum, and because this is a very big thing in our teaching and discussion about quantum entanglement. Now, science is pretty amazing because in recent times, more and more people are going into the field of quantum computing, and so on. So I guess humans, we are more receptive towards this kind of scientific idea. And guess what they have appointed for the Nobel Prize winner in 2022? Well, they have actually awarded the Nobel Prize in Physics 2022 to 3 gentlemen, right? And the Nobel Prize in Physics 2022 was awarded jointly to Alain Aspect, John F. Clauser, and Anton Zeilinger for experiments with entangled photons, establishing the violation of Bell inequalities and pioneering quantum information science. Okay, so you can read all about it and enjoy it. And the point I'm making is that we have come a long way. We've come a long way where just a few hundred years ago, science through the Newtonian era, where 1 + 1 = 2, right? And then through Einstein, it has progressed way beyond, and that's where people can calculate like what is the time you depart from here to fly to the wind, the velocity and everything, and what time you're going to arrive. And I guess the same way they send people to the astronauts to the moon and to Mars and so on, right? So this is the old science, the old era. When it comes to quantum mechanics, quantum science, it's a little bit different, all right? But just because you don't see it doesn't mean that it does not exist, all right? So that's the awakening, if you understand. And now, even the Nobel Prize have acknowledged this. And I think from where we are right now, it's going to be very exciting, where we are right now. Because just slightly more than 100 years ago, we were using horse carriages. And you just wind back the clock, I think just about 400 or 500, I can't remember, but just not too long ago, they thought that the earth was flat. Then they thought that the earth was, something else, right? And then they thought that earth was the center of the universe. Then they thought that the sun was the center of the universe. And then this kept on changing. So as we now know, there are more than 2 trillion galaxies. Yes, more than 2 trillion galaxies. It's just mind-boggling, isn't it? The Milky Way is one galaxy, and imagine Milky Way is so huge, and we have some galaxies are even bigger than the Milky Way, and we have more than 2 trillion in the universe. So science is only as good as the ability of the scientists to predict, all right, to know what's out there, and it gets replaced. So sometimes it's just theory, right? Because as we understand more and more about the universe, then we keep changing our views. So I have one more experiment which is to share with you, which is the most important of all, which is the double slit experiment, right? Now some of you may already have heard of this double slit experiment, and this is Wikipedia. Way back in 1801, Thomas Young, a scientist, actually did an experiment using light, photon, and if he shines through one slit, it will show particle behavior. In other words, at the back there will be one line, all right? But if he puts 2 slits, double slit, then at the back it will not be 2 lines, but it will be interference pattern. So interference pattern is like many lines, all right? So if you put water, wave, anything, then you let it pass the 2 slits at the back, it will be like interference pattern. So this went on for many, many years. Since 1801, nobody could really explain. So in other words, matter can be particle or wave, depending on how you use it or do the experiment. Then they tried out with electron and many other stuff. And what they have found out also is this. I mean, if there are 2 slits, it will be interference pattern. And then if you put a device or an observer to observe the whole experiment, guess what? The interference or the wave, function of the matter, it will become particle, right? So if you put an observer, a device to observe the whole process, it's not going to behave like a wave, and it's going to become particle, and you will see 2 lines at the back of the experiment. So this is really, really interesting, and it has a lot to do with our teaching, all right? So this is something about consciousness, and it is also about mind over matter. It is about whether we want to use it as a wave or use it as particle in our consciousness. So with that, I hope you enjoyed this video, and you can certainly research more and understand more, and it's very, very interesting.